Example 5. Determine the volume by revolving the region about the line y equals -1. The region will be bounded by y equals x squared plus 1 and y equals x plus 3. So the first step you have to do in this problem is graph it. If we graph this function, we see that we get the line y equals x plus 3 right here, and the line, or the curve, x squared plus 1 here. And you can see the intersection points are -1 and 2. So what we want to do is revolve this region about this line right here. And if we do that, you'll see that we get something that looks like this. And so what we need to do is we need to determine the volume if this thing rotates about. If we were to rotate this shape, we would get something that looks like this. And so what we get is we get a washer that's going to be in between, where its inner radius is going to be the distance of this curve plus 1, and then the distance of the outer curve plus an additional 1. And so if we have that on our own paper, we should identify each piece. So this is y equals x plus 3. This one is y equals x squared plus 1. And the bottom line is y equals -1. And what we want to do is take this shape and revolve it around this line. So what we need to do is identify our inner radius and our outer radius. So our inner radius, if I pick any point I'll choose here, is going to be the distance of x plus 3 to the x-axis, and then an additional 1 to get to the line y equals -1. Similarly, if we were to look at this point, it would be x squared plus 1 with an additional 1 as well. So capital R is going to be x plus 3 minus -1, which will give me x plus 3 plus 1, which is x plus 4. The reason we subtract is because if the line was up here, we would have to subtract some of the distance. So we always subtract and then the y value that we're revolving around. And then little r is going to be x squared plus 1 minus -1, which is x squared plus 2. So if we revolve it, we're going to get a shape that looks something like this. And what we want to do here is illustrate the discs. As you see, the inner disc gets larger as you move away from the center, as does the outer disc. So if we were to draw the cross section of each one, we get something that looks like this. So we get a cross section that looks something like this, where the inner one to the outer is capital R, which we determine to be x plus 3 minus -1, which gives us x plus 4, and little r, which we determine to be x squared plus 1 minus a -1, which gives us x squared plus 2. Again, revolving it, we get a 3D shape that looks something like this. And if you look closely, you can see the cross sections, which are right here. Now that's all that's left to do is set up and solve the integral. So we have, this is the integral from -1 to 2 of pi f of x, or let's call it, instead of f of x, capital R squared minus little r squared dx. So we get this is from -1 to 2. I'm going to bring the pi outside, and I get capital R is x plus 4 squared minus x squared plus 2 squared dx. If this is on a graphic calculator portion of the test, you could just plug that in and be done. However, if it's not, we must solve it by hand. And so this is going to give me 162 pi divided by 5, which is approximately 101.787 units cubed.